Okay, on C and D, we're going directly into the quotient rule. All right, so I'm not going to write out each step like the previous ones. So we're going to go on this one. We have the natural log of x over x minus 2. So you always start with the denominator. So x minus 2 times the derivative of the natural log of x, which is 1 over x. Okay, minus the natural log of x, that's the top, times the derivative of the denominator, which is 1. So that's not so bad. And that is divided by x minus 2 squared. All right, so we got to clean that up a little bit. We can't leave a fraction in a fraction like that. So what I think I'm going to do is just think of this as, so this equals, so we're going to have 1 over x times x is 1 minus 2 over x, okay, minus the natural log of x over x minus 2 squared. I'm just really curious to see if she left it like that. I would be really, really shocked on C. Let's take a look here. Does not. Okay, which is good. All right, so what she ends up doing here, and this is a good move. I need a common denominator of x all across here, and if I did that, you could think of this as 1 over x minus 2 squared off to the side, and then all of those will have an x. All right, so if this one has an x, all right, and I'm going to send that common denominator to the bottom of the fraction. If you need some more explanation on this, I can do it in class. But what's happening is I'm doing this is my common denominator. So this one needed a x over x. That one didn't need anything. Okay, and this needed to be multiplied top and bottom by x, just that natural log. So it'll be minus an x natural log of x. And there we go. So notice what I did. The common denominator is here. So this is the common denominator for my numerator, and I went ahead and sent it to the bottom. But then I had, if I was going to use that as a common denominator, then I needed this multiplied by x, this nothing, and this multiplied by x. Now, so what you can always think of then is the two denominators, the one that I'm going to use in the top and the one that's on the bottom, can just simply go together. Okay. All right. Again, if I need to talk about that one a little bit more, we will. All right. So on D, so I'll call this dy dx or y prime. It doesn't matter. All right. So I've got my denominator, 1 plus cosine x. Okay. And the derivative of the numerator, the derivative of sine is cosine. All right. Minus the numerator, the top. And the derivative of the bottom. Well, the derivative of the bottom, that's going to be 0. And this is going to be negative sine x. Okay, I'm really feeling like a Pythagorean is about to happen. And so my denominator then is going to be 1 plus cosine x squared. All right, so here we go. So let's clean that up. So distributing the cosine here, I end up with cosine plus cosine squared. All right, and this is plus sine squared. Oh my gosh, that's a Pythagorean. And matter of fact, the whole numerator is going to end up being what I've squared on the denominator. So that's a pretty awesome problem. All right. There's never really going to be a time you're going to want to square out that denominator. Just kind of leave it alone. Now, back reminder here. This is your basic Pythagorean identity. The cosine squared and the sine squared together are equal to 1. And so that means this whole thing then is, let me go back to the pink. We've got a cosine x plus green 1, and all of that is divided by 2 of those, or 2 multiplied together, I should say. 1 plus cosine x squared. All right, and that works out nicely, and so that simplifies. The numerator cancels completely with one of them in the denominator, and so I end up with 1 over 1 plus cosine x. So that is pretty good. Okay, now, and at the bottom, we have a little reminder, or not a reminder, but just a rule here that you do not take the derivative of those simultaneously. That is not how you do a quotient, okay? It's a complicated rule. We didn't prove it, but there are plenty of proofs out there, and I might throw one out there if you're interested to see the video. And then, is that the same as before? No, the high and low. So this time we have a high and a ho. So it's ho d high minus high d ho over ho ho. Oh my goodness.